So when we ask what is the mechanism of a particular reaction, we're really trying to say, how does the reaction happen? We're trying to describe the steps involved in the reaction. So let's think of this in terms of an example. So imagine we're looking at the reaction which is the nitration of benzene. So we've got benzene, we react it with the concentrated nitric acid, and we get nitrobenzene formed and water. Okay, so this is what happens in the reaction, and we need to understand how this happens. What are the steps that happen here? Now, this reaction has to have a particular catalyst for it to work, and the catalyst is sulfuric acid. So the sulfuric acid is needed for this reaction to happen. Okay, so the mechanism for this, it's part of a number of mechanisms, as part of a group of reactions that we've looked at already, and this is called electrophilic aromatic substitution. So electrophilic because it involves something called an electrophile, which likes electrons. We've got aromatic because benzene is one of the aromatic compounds, and substitution because this group here replaces one of the hydrogens that was on the original benzene ring. So we're trying to describe how this process happens. And to do this, we use the concept of where do bonds break and where do bonds form, by showing curly arrows to show the movement of pairs of electrons. So this mechanism happens in two stages. So in stage one, in this stage is the formation of the electrophile. In this case, this is from the original concentrated nitric acid. How do we get, in this case, our electrophile, which is going to be this NO2 group? How do we get that? Okay, so I can draw this out, this reaction, and this is where the sulfuric acid is important. So I start with I've got my nitric acid, and what happens is this will react with the sulfuric acid, and it will form an intermediate result, which is HSO4 minus plus OH. Now you should notice here, one of the things I'm doing here is I'm using the molecular formula because I want to see the structure where the atoms are in the molecule to be able to determine which are the bonds that form and break. Whereas in the general reaction, I've got the molecular formula. Okay, so where do the bonds break and form in this? So what's going to happen is I'm going to have a bond breaking between this bond is going to break between this oxygen and this hydrogen in the sulfuric acid. So I have this pair of electrons in this bond are moving towards this oxygen, and I'm going to have a bond formed between this oxygen and this hydrogen. So that will end up with, because now I have an extra hydrogen on this oxygen formed from this bond, and this, my original sulfuric acid, has lost a hydrogen. Originally H2, now it's HSO4 minus. Okay, then there's another step, another stage in this formation of the electrophile, because this is still not my electrophile that I need. So what happens then is if I rewrite out this, what's going to happen then is I will have this bond breaking here, and this oxygen, which has got an extra pair of electrons, will form a double bond with this nitrogen. So that gives me then H2O as a product and my NO2 group. And this is going to have positive NO2 plus. Okay, so that was the first stage of my mechanism. That's the equation. It's an electrophilic aromatic substitution, and the first stage is the formation of the electrophile, and the electrophile in this case is this group. And I show how this is formed by showing the bonds that break and the bonds that form to end up with my electrophile. So the second stage is the actual substitution happening, and they all follow the same format here. I've got the benzene, I've got some sort of electrophile. The electrophile will join onto the benzene ring, and I'll be left with one of the hydrogens. So the electrophile is going to replace one of the hydrogens. So this is the general reaction that I'm now going to look at the mechanism in terms of my nitro group. Okay, so we formed this electrophile. By the way, this electrophile, this is known as a nitronium ion. Okay, so then now the process is going to happen as we've seen before. I have the benzene plus my NO2 plus, and what's going to happen is a bond is going to form between this electrophile and, let's say, this carbon here. So what's going to happen is I'm going to have electrons will come from the delocalized ring to allow a bond to be formed between this carbon and this. I'm going to draw it up here. Let's say it's between this carbon and the hydrogen. But this is an unstable intermediate ion. So this is an intermediate carbocation that's been formed by this group forming onto the benzene ring, and the benzene ring no longer has its stabilizing delocalized central ring. What happens then is from this the bond is going to break between the hydrogen and the carbon, putting the pair of electrons back into the ring to give me nitrobenzene and hydrogen. Then finally that proton, that hydrogen that has been released, will form a bond with the sulfuric acid that lost one of its hydrogens. This will form a bond with oxygen to give us back our sulfuric acid. So in the mechanism, what you're doing is you're starting with a reaction, and you need to describe how the reaction happens, and you're showing that through the breaking and forming of bonds, showing the movement of the electron pairs. And in the case of electrophilic aromatic substitution, it's always in two stages. First of all, you form the electrophile, in this case the nitronium ion, and in a second stage it's the substitution itself mechanism that you need to show.